Hey there folks, In the last video, we installed the SAS HBA into the system and routed the SATA breakout cables to the back of the frame. Continuing on in that vein, we'll start this video with the construction and installation of the power cable for the SSDs. This cable will run from the power supply, through the transfer area, across the panel grid, down the left rack column, up the middle column, and finally back down the right column. The two types of connectors we'll use for this cable are a 6-pin connector at the power supply, though we'll only be using 5 of the 6 pins, and SATA punchdown connectors along the run where a drive is located. The pinout mapping for the C1200 power supply is as shown here. This cable will be made using 17-gauge wire, so I'll cut 5 links that are each 4 feet long from the spool. The 6-pin power supply connector takes the long wing, female ATX PCIe EPS pins we've used several times in this series to make the motherboard and EPS cables. I'll strip the insulation from one end of each wire and crimp on the pins. After all 5 wires are prepared, I'll insert them into the 1, 3, 4, 5, and 6 numbered holes on the 6-pin connector. The number 2 position does not get a pin when making this particular cable. Using masking tape and a Sharpie, I'll put a label on each wire that corresponds to the pinhole on the connector. From the back of the frame, I'll push the 6-pin connector through the power panel opening and then insert it into the power supply using the next available peripheral connector plug. Next, I'll sort and organize the wires into the panel's grooves. On the back of the frame, I'll attach a 5-wire clasp using an M2.5 6mm screw to the right of the transfer area. The tracks on this clasp perfectly contour the edges of the 17-gauge wire. Now I'll insert each wire into the tracks, with wire 1 going in the bottom track, wire 6 going in the next track, followed by 5, then 4, then 3. After all the wires are in place, I'll add a cover to the clasp using M2 6mm screws. To ensure the next clasp is placed in alignment with the first SSD, I'll insert a punch-down connector into an SSD and slide it into the top left slot in the rack. I'll now add another cable clasp above this connector in the grid position that results in a straight shot to the SATA connector from the clasp, or as close to that as possible. In the right track and working to the left, I'll insert wire 3, then wire 4, then 5, then 6, and finally wire 1. I'll add another cover using M2 6mm screws. The most important variable to get right with this cable is the position of the first SSD connector, so I'm going to perform the first punch down on the back of the frame itself. I've selected a helper SSD that won't be missed if I destroy it. Many SSDs have really flimsy power and data connectors, and there's a risk when applying the punch down pressure that the internal connection will break and the drive will be done. I've done that a time or two. First, I'll get the wires in order, pressing them lightly into the grooves with my fingers. Then I'll use a standard telecom punch-down tool, and specifically the non-cutting end of a Type 110 head, to punch each of the 5 wires into the grooves. It's okay if the wires aren't fully punched in at this point, since we're going to be removing the cable to perform the rest of the punch-downs. But they do need to be solid enough that they don't slip out and thus misrepresent the true starting point for the SATA connectors. I'll temporarily add a short cover to the SATA connector to keep the wires in place, undo the 2 clasp covers, carefully unplug the connector from the SSD, remove the wires from the clasps, unplug the cable from the power supply on the front, and pull the connector back through the power panel. To demonstrate how we'll attach the rest of the SATA connectors to the cable, I'll add 7 SSDs into the middle column on the rack. Each drive also has an empty punch-down connector in the power plug. I designed the rack spacing so that the power connector on each SSD is perfectly aligned to one of the spacing patterns on this acrylic Molex power connector punch-down block. This is a very handy tool that allows me to construct cables whose connectors align perfectly to the power plugs on hard drives, and to be able to make those cables without needing actual drives during the process. I just need to make sure the position of the first connector is accurate for the build I'm working on, and then everything else will work out by using the spacing block. There are 2 kinds of covers for punch-down style SATA connectors: short covers and long covers. Short covers are placed on connectors where the wires pass completely through from one connector to another, and long covers are placed on the last connector on the cable, with the long side covering the ends of the wire cross-section that are left exposed once the excess wire is cut off. There's only going to be one long cover used, and that will be on the last connector we add. All of the other connectors will get short covers as part of punching them down. I'll insert the first connector we've already started into the block and perform another punch down to ensure the wires are fully seated into each groove. Next, I'll raise the wires up gently, plug an empty connector into the slot just below this one, pull the wires taut, punch them down, and add a short cover over both connectors. 2 connectors down and 17 to go. To remove the connectors, I'll flip the spacing board over and press on the plastic of each connector, not the pins, with a small flat-edge screwdriver. Now I'll inspect the housings to make sure the wires have been fully pressed into position and that the covers are secure. For the next connector, I'll very gently bend the first connector up, insert the second connector into the top working slot on the spacing board, insert another empty connector, position the wires, and punch them down. Rinse and repeat these steps until the first 7 connectors have been added. With those 7 connectors finished, I'll slide 3 drives in the left column, and then connect the cable to make sure the plugs align with the drives, and they fit like a glove. Next, I'll add another drive in the bottom slot of the middle column, and repeat the steps thus far, starting with the alignment of each wire into the corresponding groove, temporarily securing them into place by using the punch-down tool or a flathead screwdriver, disconnecting the drives, moving back to the spacing board to add the next 7 connectors, and then coming back to the SSD rack to test out the spacing. Once again, the plugs align perfectly to the drives. With the drive in the second slot from the top in the right column, I'll repeat the steps again to pre-position the first connector, and then move back to the spacer board to finish things up. The first 5 connectors will be added just as the others have been on this cable, but the last connector is a little more special. For this one, I'll flip the punch down head so that the cutting side is being used, and with the sharp edge facing the side of the connector where the wire ends, angle it slightly down while completing the punch. Unlike a traditional network cable punch down, I have never once had the head cut cleanly through wire this thick, but it does put a nice gash into the wire to start with. To finish separating the wires, I'll use a snap-off utility razor to slowly stroke back and forth over the top of each wire. Before closing things up for good, I'll inspect the cut ends to make sure they are clean and flush against the housing. Once it looks good, I'll add a long style cover so that the long side is covering up the exposed wire ends we just cut. That completes the construction of the SATA power cable, and now we can permanently install it on the frame. I'll insert 6 drives into the rack, representing the top and bottom slot in each column to validate for the final time that everything lines up perfectly. Satisfied with how things look, I'll add the wires back into the clasps, along with the covers, and push the power supply connector back through the power panel opening. From the front of the frame, I'll insert the plug into the power supply and add 2 small pieces of Velcro cable tie to ensure the wires stay bunched together nicely. And that wraps up making the power cable for the SSDs. Next, I'll install the memory. I'm using 2 sticks totaling 32 GB of G.Skill Trident Z5 dual-channel DDR5 memory. With only 2 of the 4 memory slots occupied on the motherboard, the recommended placement is for 1 stick to be placed in the A2 slot and 1 stick to be placed in the B2 slot, so I'll press them into place according to that orientation. I'll also reattach the M2 heatsink over the NVMe slot nearest the CPU. This isn't actually going to be cooling anything since there isn't a drive in this slot. I'm mostly adding it back so that I don't lose it, and also I think it looks a little nicer than not having it in place. I'm also curious of the total airflow through the SSD rack, so I'll quickly test that as well. I'll turn the machine on, and using a digital anemometer, can see that there is a 216.5 feet per minute of airflow coming through the rack. Personally, I'd refer to this amount of airflow generally as enough to keep the drives cool. Another thing worth mentioning is that the 20 connected SATA drives will only hold game files. When it comes to building out tons of raw SSD storage space, this is awful hard to beat. While the performance of the individual drives in this array wouldn't hold a candle to even low-end NVMe drives, the extra speed of NVMe doesn't equate to that much better of a game experience in the vast majority of scenarios. For example, an NVMe capable of write and read speeds 10 times faster than a normal SSD, which tops out at roughly 540 megabytes a second, does not load games 10 times faster. Not even close. On the topic of SSD speeds, I connected a cheap and very old SanDisk drive to run a few benchmarks. The CrystalDisk numbers on the left are when the drive is connected through the SAS HBA, and the numbers on the right are when the same drive is connected directly to a motherboard SATA port. This is plenty fast for storage and retrieval of game files, and this kind of setup has served me very well in that capacity for years. Additionally, if I ever reached the point where 150 terabytes wasn't enough to hold my game collection, I could easily add a SAS expander into the setup and immediately gain access to another 24 SATA ports with no change to any other part of the build. Though it should be noted that SSDs connected through most SAS expanders lose between 15 and 30% performance. There are some models that are better at maintaining closer to stock performance numbers, but those expanders are pretty expensive and certainly not readily available on sites like Newegg or Amazon. And that, boils and ghouls, is the finished wall-mounted computer frame. Here's a few shots of how things look with all the wiring, cabling, and organization complete. Between the soldering, 3D printing, delidding, water cooling, cable making, and more that we've done in this series, I hope there's been an interesting tidbit that you might be able to use in your own projects. In the future, I'd also like to show you the kits I've designed using 3D printed and CNC'd components to make assembling a frame like this easy and pretty darn fast, but that will have to wait for another day. In terms of migrating the existing drives into this system, about half of these drives are 8TB Micron SSDs that will eventually make their way over, but there is a substantial amount of effort required to ensure that I don't lose the customizations I've made to over 10,000 games in the process. It should be the last time it's hard though, because I'm working on a transfer process that should make it easier if, or when, I need to do this again. With the computer build now complete, let me provide a preview of my roadmap moving forward. The first new series will convey a detailed breakdown of my Windows installation procedure and each tweak I make to the OS to get things ready for gaming. Once that series is complete, I plan to transition into another series where I share some of the details for how I've built out what I consider to be the ultimate gaming ecosystem, perfectly bringing together games from Steam, Epic, GOG, Rockstar, EA, Ubisoft Connect, custom games, emulators, ROMs, and more into one consistent interface, while solving some of the biggest headaches I've encountered over the last 30 years of PC gaming. For the last time, until the next time, I hope you've enjoyed this demonstration. Thanks for watching, and out.